Yes, dear viewers, you are welcome to this session of physics. Today we are going to talk about waves. I'm so delighted to have you tonight. So we want to talk about waves. We want to see the concept of waves in physics. A very interesting concept. So dear viewers, when somebody talks about a wave, what runs into your mind? Oh, a wave by definition. So what is a wave? Oh, I'm seeing my students in class are trying, Yes, they are trying to try. Okay, can you tell us what a wave is? Oh, you can't hear her, but I'm hearing what she's talking about. She's talking about a disturbance in a medium. Very good. Disturbance in medium. So we have got a new word. Disturbance in medium. Not only a single word, but there are two words. We are getting a word medium. Medium. So medium is any state of matter. It can be a solid state, it can be a liquid state, or it can be a gaseous state. That is a state of matter, that is medium. Now we can talk of disturbance. When we talk of disturbance, for example, if I have a source of water, for example, this is water, and I happen to disturb it, then that creates the topic we are going to talk about tonight. So we are going to define a wave as a disturbance through a medium which transfers energy from one point to another point without causing any permanent displacement of the medium itself. Just the transfer of energy. Very interesting. We need to first put that down. That a wave is the disturbance through a medium, is a disturbance through a medium, through a medium that now involves transfer of energy, or which transfers energy. So which transfers energy from one point of the medium to another, or to another, without causing permanent displacement of the medium itself. So without causing any permanent displacement, displacement of the medium itself, A very wonderful definition. A wave is a disturbance. So this is a marking point. It has to be there through a medium from one point to another. Then you need to talk about that there is no cause of permanent displacement in the medium itself. So those are very major aspects in the definition of wave. So people are asking, teacher, what are you trying to talk about? Is what you are talking about applicable in daily life? Exactly. You are in position to see me today because of this concept. Visible light, which allows us to see. The microwaves and radio waves, which allow a long-range communication via mobile phones, via TVs. Imagine somebody is broadcasting or telecasting from a studio and you are watching from home. Look at me now, where you are watching me from. Concept of microwaves and radio waves. The infrared waves, we shall talk about infrared waves, which are used in night vision cameras and in many remote control systems. For example, people who are watching me on DVD, you inserted your DVD using a remote, And those are infrared waves or radiation. The X-rays, which are used in medical examination, measured in medical imaging or imaging. Can you imagine? It's the concept we have come to introduce today. These waves, we are going to see that they are used in design of security systems, like the burglar alarm systems, rodent repellents, in designation of fathometers. That is an instrument which is used to measure depth of the sea, the fathometers. Even in construction of the blind devices, or devices for the blind, you see blind people holding sticks and what have you. Those devices. In teeth cleaning, we are going to use this concept of waves, and those are ultrasonic waves used in teeth cleaning. In the killing of bacteria, in particular solvents, that is concept of waves. Construction of dog whistles. I cannot exhaust the whole concept of waves. We shall see that even pulse waves, which are used in analysis or in detection of hypertension, coronary artery diseases, that is in the medical sector, are also very, very useful to our life. These waves in the treatment of cancer, however much they are also a major cause of cancer, as we shall see with the time. Different waves, and mostly electromagnetic waves. So this is a very, very good introduction for waves. Now, let us try to go and see who are these famous scientists who started this concept of waves. The study of waves dates back to the ancient Greeks, who observed how vibrating strings of musical instruments would generate sound. That's where it started from. All the way in 300 BC by a gentleman known as Euclid, who was a Greek mathematician, but mostly lived around Egypt. Euclid. And is often referred to as the father of geometry. Then discoveries went to Galileo Galilei, an Italian scientist, who is regarded to be also a grandfather of modern technology. Then talk about scientists like Kepler, Johannes Kepler, who was a German mathematician, a philosopher, a scientist, a physicist. Then talk about Christian Huygens. You talk about him with time, Christian Huygens. You talk about Huygens' principle of now light waves. This one majorly based on light waves. He was a Dutch mathematician, a philosopher also. Talk about Jacobo Bernoulli and then Johann Bernoulli. Yes, those people who lived around the 16th century, those were Swiss mathematicians, the Swiss mathematicians. They all contributed to the concept we are going to talk about today. Okay, but now major contribution was done by the son of Johannes Bernoulli. So Johann Bernoulli produced a son by names of Daniel Bernoulli. So you have ever heard of what we call the Bernoulli's principle. That is the son of Johann Bernoulli. These are all Swiss mathematicians, all the way from Sweden. Okay, then you cannot forget talking about Sir Isaac Newton. Because now visible light, which is helping us to see dispersion of light and what have you, light waves, all that concept was dealt with by Sir Isaac Newton, the grandfather of physics, if I can say. Then talk about Al-Hazim, that was an Iranian mathematician who talked about the pinhole camera. Those are light waves in a camera. Okay. Also another Iranian mathematician, that is Ibn Sahil. Okay, the gentleman who discovered the law of reflection of light, the bouncing back of light waves when they fall onto a highly polished surface. So talk about scientists like René Descartes. Yeah? René Descartes or Descartes. Okay, this René Descartes is regarded to be the father of geometry. The father of geometry, a philosopher. Okay, so actually is the modern father of philosophy, René Descartes, who was a French philosopher. So you can go and make Google searches about these people. They will inspire you. Maybe you can also come up with something very, very interesting. Scientists like Archimedes, Robert Hooke, talk about Joseph Fourier, who was a French mathematician, Thomas Young. There are very many. Robert Einstein. All those contributed to the concept I'm introducing today. A gentleman like Gauss, Christian Doppler. All those are different scientists. James Clerk Maxwell, Heinrich Rudolf Haas. This Rudolf Haas, when you go to Google, when you talk about waves, Google will bring for you Haas, who was a German physicist, died when he was very young at the age of 36. And this is regarded, Thomas Haas is regarded now to be the father of, radio wave improvement. The reason why you can see me today is because of this gentleman's development. He developed James Clerk Maxwell's idea of electromagnetic waves, or radio waves in particular. So that's where our topic starts from. Now, after seeing that a wave is a disturbance through a medium, I want everybody to create his or her own wave. Tell me what you are going to see. Get a basin full of water. Try to disturb it. Go and push your palm onto the surface of water. Observe what happens. If that is not enough, can you get a rope? Get a rope, tie it at one end. Okay, this is the rope. Tie it at one end. And then hold the free end of the rope. Then try to swing it. Oh, when you swing it, you are going to see different features. It will behave like a snake. I believe that's what you have seen. If you have not done it, immediately after this break, I'm directing you to go and do it. Get a string or a rope, tie it somewhere, and try to swing it. What do you observe? That is now the disturbance in the medium. However, that disturbance in the medium is not going to cause a permanent displacement of the medium. It is just a temporary, disturbance in that medium. So immediately after a break, tell me whether you have achieved this or you have got any disturbance in any medium. We have used the medium of liquid. This is a liquid. You can get water or a state of matter, also a medium which is known as solid, because air may not be easy to demonstrate waves through it. So immediately after a break, tell me what you have done, what you have achieved. Have you done that experiment? Stay tuned. Yes, dear viewers, we'll be back from the break. So we are progressing slowly by slowly. Hope you have demonstrated a wave propagation, how there is a disturbance in a given medium, and how that disturbance only occurs temporarily, but does not displace the medium as a whole. Now let us go and talk about the topic outline. What are we supposed to look at in this concept of motion? In this concept of waves. What are we supposed to talk about? So basically, we are going to start with what we call the general wave motion. General wave motion. And under this, we are going to talk about the different categories of waves. This general motion, wave motion, is going to be divided into two. We are going to talk about the mechanical waves or mechanical wave motion. Mechanical wave motion, like the one you demonstrated was mechanical in a magnetic. So secondly, we are going to talk about the general types of waves. Types of waves. Okay, so when you go to the internet, there is a misconception. People are talking about the types of waves as transverse and longitudinal. But we are going to see today that waves are of two types. We have what we call the progressive waves, and then what we call a standing wave or stationary waves. So stationary. When we talk of progressive, before I go to stationary, then the progressive waves also has its own types. And these types are the longitudinal and transverse. So longitudinal wave, for example, the sound waves, and the transverse waves. So what you normally find on internet as types of waves, those are just types of progressive waves. We are going to see what a progressive wave is. So these are categorized into longitudinal and transverse. Another type of wave is we have talked about a standing wave or stationary wave. Stationary, in brackets, standing wave. Okay, so that is number 2. Then number 3, we are going to talk about the general terms which are used in wave motion or in waves. So general terms used in waves. So among these terms, we are going to talk about displacement of a wave. Since this is motion, so we need to talk about all those. Displacement of the wave, what we call amplitude, crest, trough, wavelength, period, wavefront. There are very many terms. So I can list for you some. So among the general terms used in waves, we have displacement of the wave. Okay. Let us start with, since a wave, when it is displaced, it gives what we call the amplitude. Let us start with amplitude. Amplitude of the wave. Then what we call wavelength. What we call a crest. What we call a trough. Okay. What we call a rarefaction. I don't know whether that is the SP, rarefaction. What we call a compression in a wave. What we call a period. Yes, what we call period. This is a common term, period. We normally use it. So what we call, what else can we add? We can talk about, yes, wavelength, we have already talked about it. Then there is wavefront, the wavefront. So we can stop there on the wavefront. What do we call a wavefront? So there are many terms, but these are the general ones. Then number 4, okay. Number 4, we are going to talk about the wave properties of these waves. We are going to see that waves can be reflected. They can be refracted, that is bending, like the light waves. They can be diffracted, okay, that is spreading of waves, okay, when they fall into an obstacle. And then we are going to see that there is interference of waves. Waves do undergo interference. So wave properties. So wave properties of reflection of waves, then refraction, then diffraction of waves. Then there is also dispersion of light waves. Yes, as discovered by Sir Isaac Newton. Dispersion, but we shall not go into that. We shall look at that in a specific light, the concept of light, that is dispersion. Then we talk about interference of waves. So those are some of the properties. Then this will take us now to do a general look at what we call the sound waves and their properties. And we shall see that the sound waves fall under what we call longitudinal waves. That is part of progressive waves. Okay, so sound waves, and properties, and properties. And among the properties of sound waves, still reflection will come in as property. We shall talk about the speed of the sound waves. So speed of sound waves, and we shall discover that this speed is around 320 to 340, between there, from 320 to 340 meters per second. That is the speed of sound wave. Then we shall also talk about the speed of these waves in a vacuum, the sound waves in a vacuum. So speed of sound waves. Then we shall talk about reflection of sound waves. Reflection of sound waves. Did you know that sound waves can be reflected? Oh, okay. And under reflection, that's when we shall talk about the echo sounding. Okay, what we call an echo, and then ultrasonics. I can quote them here. So echo and the ultrasonic sound waves. As we saw at the preamble, how they are very, very useful in the measurement of the depth of the sea, using a bathymeter, making devices for the blind, very, very many, okay, in killing of bacteria, in solvents, and so on. Then we shall also talk about musical instruments and their properties, Okay, we shall talk about noise. When does a musical instrument produce noise, reverberation, okay, due to a musical instrument. Then acoustics of a building, we shall talk about them under what we call musical instruments. And then these musical instruments, we shall further talk about vibrating strings, because most of them, they work on vibrating strings. So in brackets you can say vibrating strings. So there are many properties of these sound waves, which we shall talk about. Then from there we shall go and number 6 talk about waves which are produced in pipes. Okay, waves produced in pipes. Okay, so among these waves we shall see how waves now produce what we call resonance. Properties of waves produced in pipes. That is open pipes and then closed pipes. Waves produced in pipes. That is open pipes, and closed pipes, and closed pipes. So here we shall talk about resonance, setting the material into vibration at its natural frequency. So among the terms which I never actually talked about here is frequency, and then maybe speed of the wave. But those are very, very common terms. So immediately after a break, we are coming with the real beginning of this concept of waves. We want to start with wave motion, the mechanical wave motion, and then electromagnetic wave motion. Then we shall go to the types of waves slowly up to when we reach waves produced in pipes, the concept of resonance. How is the concept of resonance used to determine the velocity of sound? Okay, so immediately after the break, don't go away, we are coming back with a real introduction of our waves.